formulate their ideas. So take it away.
Okay, the first thing is I think everybody should have in their hand a little tiny scrap of paper and use the blank side of the paper and just give us your personal guess or your whatever you want to base it on, September mean CI 610. What I promised is after lunch I'll show you the distribution, whatever it is. And you know, it's just data. You don't have to sign your name, although if you want to, you can. And it doesn't necessarily have to go any farther than this, but I'm curious. And you know, it seems like something we could do. See where we stand. How about just one decimal place? Because somebody's got it. Has to type these into a computer during lunch. In millions of square kilometers, you know. So we'll get the mean and the median and the outliers and the skewness and the kurtosis and anything else you want after lunch. And while you're thinking hard about that, I have something else I'd like to bring up. And something just came up that sort of illustrates a point that I think I was making yesterday, and Nevin certainly was making, regarding how the CIS blog and things like that are something new in the larger community that's paying attention to us. And it's a little bit critical, but what I've got here is just a comment that was posted on the blog this morning by somebody who was following our session here this morning and had a reaction to it already. And I think this may be something a little bit different from what people are expecting. See if I can find it again. Okay, here's the quote. Phil Jones' summary just now suggested our blogging friends want to see lots of plots. I thought Nevin made it clear yesterday that actually we'd like to be able to download lots of data. So, as I say, something new under the sun, something we're not used to interfacing with, but just an idea to keep in mind. So.
Thanks, Larry. So he did say lots of plots too, didn't he? Or no, he was making lots of plots. That's right. So he definitely wanted data. Okay, we will keep that in mind. We will now talk about the breakout groups. And starting with Group A, for the recommendations of the next sea ice outlook. And I was in that group. I think it's Alice, right? So take it away. We have only about 35 minutes and 8, so be brief.
It's now been an hour. I have to look at the notes. All right, so we had 3 topics to cover because of consolidation. So the first one was on the topic of outreach and kind of community communication. And the conclusion was everybody blog more. You don't necessarily have to use your real name. Don't necessarily use your credentials if you don't feel comfortable with whatever you're saying and attaching it to yourself. But put things on the internet and make sure you have people who know what they're talking about out there too. So then the second, I just got taller. So then the second area was looking at the CIS outlook and recommendations, kind of moving forward from that. And the big thing was we want more information from contributors. Not necessarily that we're should be requiring it right away, because that information may not be available, but things like statistics on there, predictions, information on how they made the predictions, assorted other bits of information that some groups may have readily accessible, some groups may not, but with the ultimate goal of going towards kind of standardized figures, products, having some kind of standardized goals that you can compare more easily between different predictions. And that can be partly done through the CIS Outlook kind of submission process, and have the everybody needs to give this information, and then have the next section of, if you've got this information, please give it, with the idea that over time, more of the kind of optional information will become required. And that Drew's spaghetti-shaped map with probabilities is really useful, and we should be requiring that for more predictions where possible, instead of just using a single number. And then we also got into regional versus Pan-Arctic predictions, and how the regional predictions are really what's more useful for kind of users on the ground, but that it kind of diverges from necessarily kind of system-wide science goals versus actually understanding if your boat's going to run into an iceberg in the next week. And so we never really came to specific conclusions on that, except for that there are multiple areas that this research needs to go in, and how to define the goals in that area is something that should be looked at more in the future. And that postseason reports are good, and everyone should think about what they did over the summer. I think that's the list.
I guess it actually would make more sense to have the group B that did the same breakout group follow, so that we can kind of compare. Thoughts? Are you ready? Did you want to present or just talk to your?
I'm presenting.
Okay. I mean, did you want to project?
Oh, no, I just have sticky notes.
Better.
All right, so from our group for Part B, in terms of improvements to the Outlook process itself, the big things that we had sort of talked about, and some of these were common themes between, I guess, Group Alpha and Group Bravo, but having more rigorous forecasts or more rigorous requirements for the forecast, so that everyone who's modeling is sort of on the same page. But at the same time, there's also the balance that we don't want to, by formalizing the process more, we don't want to discount the heuristic forecasts. I know someone had mentioned that in certain communities, like the aviation community, weather prediction is still done. There's still a lot of skill that's done by humans itself. So we don't want to necessarily discount heuristic forecasts for doing that. Another big thing that we talked about was adding uncertainty estimates with our forecasts. That's going to be pretty big. Another point that we brought up was adding validation data for those who have submitted previously. So saying, last year I submitted this was the actual thing. So if you're using different types of models, you sort of have helps you develop somewhat of a more predictive skill as to how you will stand, or how the model may stand based on your previous history with it. In terms of communicating the results, we were talking about whether or not the box or the bar chart was necessarily the most effective way of doing it. We were throwing out the idea of using box and whisker plots to do that. And I know Ed had mentioned that the UK Met Office has done a lot of work with visualization of data, and so a lot of that, the results from that could be easily transferable to how we're communicating our results from the Outlook process. On the standpoint of regional scales, we were talking about adding a spatial map and then making sure that everyone has submitted their whatever they've used in the same format, so that if we need to, we can later regrid the data, so that way we can compare spatial comparisons with each other. And then the last two things that we talked about were possibly adding the date of minimum extent at each grid point, just as in addition to having minimum extent, having where you're going to get your minimum at various points, and then using certain choke points like the McLaurin Passage or Severnaya Zemlya as easy validations of go no go for whether ice was there or not at the choke point. So. That was it in terms of improvements. And then talking about communications and stakeholders, we talked about the feedback from the public in the blog sphere, and that there may not be the need to spend a lot of time addressing the concerns there, and that there may be more pressing ways that we can communicate with the public than trying to respond in that atmosphere. So things that we might need to do are more communication to inform the public of the whole process. How are we creating those models? How are models created? How are the statistical methods done? And how does that whole process work to get this final product that we're putting out? And then lastly, communicating with stakeholders about actual feasibility of forecast skill. There was the analogy with weather forecasting and how that's evolved over the last 50 years or so. I know Ed had mentioned the statistic that for every decade of work that we've put into that, we've gained about one additional day of skill. There seems to be not necessarily that level of understanding about the inherent limits of predictability with the stakeholders. So We need to be better about communicating what we are capable of doing. If a stakeholder says we want 80% certainty, we can't give that per se. So we need to be honest and upfront and really drive that in and say this is what we are capable of doing, and we're still sort of in the research stage of this science of sea ice forecasting, if you will, and that we can't necessarily say with any certainty this is our product. We're guaranteeing what it's going to be, even if it is probabilistic in nature. So thank you.
Thank you. That was wonderful. By the way, you reporters, would you please email your reports to me, and I will try to collect them all because these are really valuable points, and I collected yours already, Alice. Thanks. I was also going to bring up our PowerPoint just so that I have a prettier list to deal with here. There it is. Where'd it go? I'm doing this with my left hand, which is never good. So the next section of breakout groups is on the design of intercomparison projects. So Group A, do we have a reporter? Drew, great. Oh wow, a trade-off at the stage here. Come on up. No.
Can't move it?
No, please don't, because it's running the webcast. So. Okay. Oh, I need to hand
So I
this
can't,
to you.
so I won't be able to, I'll have to just read, huh? Okay. Fair enough. Yeah, so we're gonna have to, I said I was all prepared, now I have to remember what I was prepared with. Yeah, so we had a very good discussion about intercomparison projects. And I think our number one kind of suggestion was that we try not to make too many new experiments, but to access what is out there in the community already. So we want to access the CMIP experiments, the CH, the historical forecast or seasonal forecast products, the opposite product, and essentially make maximum use, because a lot of these initiatives have been done and ultimately they've been underused, and we want to get maximum use. And then ultimately there are, of course, studies that we will want to do, and those are kind of in our grand ideas. So the 5 kind of short-term things that we came up with were to assess the importance of the energy balance on seasonal time scale. So we want to, in CMIP models and historical forecast models, in the opposite program, to be able to look at the importance of the energy balance. So we have to have so there may be a discussion of what exactly is needed. We need daily variables. So we need to make sure that the data is going into these products that ultimately will be required to do an energy balance, because we've decided energy balance is one of our main priorities. So that was our first one. Secondly, we wanted to leverage opposite. So I'm going to have to read this for a second. So we want to expand on their intercomparison product to make it serve our purposes, not just their purposes. I'm sure they want that too. So and of course that helps them, because they'll perhaps engage more people and they'll get actually more intercomparison products. So again, excess variables for feasibility, addressing why we have similar predictability, more variables, what are they? So again, make sure that the opposite project has the variables that ultimately are going to be needed to address interannual variability and predictability. I've lost my screen a little bit. So that was our second one. Third, communicate with CMIP 6 and CHFP so that the modeling centers save terms that we want for sea ice energy balance. So back to the first product, that again, we need the terms to save for sea ice, energy balance, and predictability. And of course, access those, get someone to access those for the communities, because of course there'll be a static when it is requested, if they have it, of course. So that was our third one, sea ice hiatus. Shouldn't have put that first, because that's going to give away the whole secret there. So the idea here is to use control experiments in the CMIP program, or control experiments out there, and since presently we want to do it in an externally forced product as well, to look at the probability of sea ice. So essentially Ed's suggestion for the high temperature hiatus, again, I mean, that's extremely useful to do in an intercomparison project, have a super ensemble of interannual variability of the sea ice, and you can get a firm prediction of what the probability of a 20-year or a 10-year hiatus in the sea ice extent is. That was a long, I didn't discuss all the things that we needed there, did we? Yeah, and of course, part of that is also the autocorrelation and predictability. So same studies can be used to do the lag correlations and inter variable correlations to essentially access that information as well. And so there's a wealth of information in essentially present day intercomparison projects, as well as externally forced or climate simulations. And finally, I must be well out of time already, scope out what is needed to do the problem with existing experiments so that we understand mechanisms underlying predictability, use daily sea ice variables. So to do a lot of these things, we're going to need daily variables. So that's going to be something that we need to impress upon the intercomparison projects. Is that obviously it's a trade-off between data holding abilities and so on. But in order to do some things well, we need daily variables, and so there's got to be a discussion of what those daily variables are. And if I got 2 seconds to say what our grand challenges are. Grand challenges in terms of intercomparison projects were, again, to look at changes in predictability in a warming climate. So look at possibly access APSIT runs for that. And then predictability experiments where you actually withhold process or control or withhold processes to actually look at parameter studies and relevance of certain processes. So that's our. And I guess you'll give her the.
Oh, yes. So, thank you.
Thank you. So for the B group, we at one point that was close to the A group. It was about diagnostics, so we should have additional diagnostics. So you mentioned the heat content, but we talk about spatial patterns, EOF, image matching. For the rest, we were closer to the grand challenge and to make additional experiments. So that's complementary. That was good to it A and B. So what we had in mind first, it was to say, what is the impact of initialization in a general way? So can we test, make simulation with common initialization data sets and then perturb those data sets to see if the data set that are used to assimilate really an impact on the predictability. But then there were the question about feasibility. Can we define the right data sets? Or can we initialize different components, and models have different way of representing the variables that looks the same? So the feasibility issue was quite important. Then the second question was related to which variable should we assimilate? Is it really important to assimilate ice concentration, or should we just assimilate ocean and atmospheric variables or whatever? So one idea would be to make a test when we start to assimilate only one variable and then we add some others. That's an idea of a kind of group of tests. We could also try to understand the impact of initialization on the model state, and then imagine that you make a test in which you assimilate a variable only, like CI's concentration, and then you modify only CI's. Then you test if you modify other variables, that you modify CI's, then you look at the impact it should have on ocean and see if it modifies the predictability. And then really on the long term, that would be interesting to make idealized test case, as we have seen yesterday, to test the source of predictability. Do we find some predictability in a CI thickness anomaly? Is a change in fresh water that would be associated with the melting also a source of predictability, or more generally in the ocean? But one of the comments was that those kind of experiments should be as constrained as possible to be able to diagnose precisely the consequence, and not to say, yes, models are different, but we don't understand why. The more constrained you are, the larger is the chance to understand what is going on.
Excellent. I think it's probably most useful if we have questions at the end, because there's a lot of overlap among the groups, and also we may not have any time. Sorry about that, but it seemed like 45 minutes was going to be so ample. Andrew, you next? Okay.
Thanks. So I was in the first design of metrics session. Well, there's an echo here. So the first thing that came up was what do we mean by metrics? And I think the most important point made in the entire session was really this all depends on what question we want to ask. And so rather than coming up with a long list of particular metrics to suit our individual problems, we need to suit it to the problem we would like to ask. And so there are two distinct streams that we can divide initially, and that is what operational forecasters would like to validate and evaluate is very different from what modelling groups are wanting to look at. So we tried to split our metrics discussions into those two streams, if you like. And so I prioritised these 5 points also. That was, I think, the highest priority. And the second priority was that probabilistic metrics. Really, we need to delve deeply into probabilistic metrics and not any exact numbers. So designing metrics along those two lines are really important, and the first and most important parts of the discussions we had. So we did come up with a list of just a few metrics as a taster to the sort of things that we might like to come up with for operations for a start, because for operations it really comes down to a question often of ice or no ice in a particular location. So in that case, you know, a skill number for the Arctic is a fairly useless thing, whereas we would like something that's regionally specific, and so dates of breakup at a particular point, the ice edge, ice or no ice types of metrics were what we'd be aiming for in that class. In the model class, we felt it might be best to aim for things that have some physical meaning in a model. So one suggestion was to do with thickness. How does thickness change over time? But particularly, thinner ice is much more likely to melt quickly than thicker ice. So any observations that can hint at that and metrics that can point to that as an indicator of feedbacks in a coupled system is a good start. And that's the sort of thing we should be aiming for. So we came up with several other ideas, but we tried to steer away from just long lists as long as our arms of any particular metric. Something else that came up was that now we have at our disposal quite a large list of models with different configurations. We have assimilated models, global fully coupled models, regional fully coupled models, regional ice ocean models. Combining all of these together gives a rich understanding of physics rather than looking at any particular class. And so we should be thinking of metrics in terms of how models and observations can interact and how we can use them using a hierarchy of models rather than any particular class of models. And of course, along those lines is the fifth point was getting the processes right and that's what our metrics should be focused on. So our big ideas was that perhaps most important point here is that there needs to be close interaction between modelers and observationalists. This can't be seen as a dichotomy of we come up with a set of metrics and we evaluate a model against it. So I gave a particular example that I think universally agreed that having sea ice thickness estimates was a really good thing from satellites. The only problem there is that we need a good understanding of snow cover. And so I've personally been approached by an observationalist wanting snow cover from our model. So we have a vicious circle there that we need snow cover from model then to create the observations by which we'll validate a model. So there needs to be continual dialogue. And the other important point for a big future thing was that rather than giving specific state variables, that rates of change of these variables is perhaps more telling for metrics for models. Thank you.
And Group B. Oh, Jen was a good note taker. Do stand on the stage and hold the microphone close.
Okay, so a number of points that Andrew just said, we also discussed during our breakout session, so I guess that's good. So we discussed first, I think an important point that was brought up is that it was more like a grand idea or overarching, but I'll start with that, saying that defining a single metric is really hard, and this is a problem that a number of communities deal with. And so there is not like a single metric that will save us and will answer everybody's needs. But we discussed that probably metrics that will be regional indicators would be important and not just like a single quantity, and those need to be defined depending on the end user's needs also. And so we discussed in particular pattern correlation and maybe identify key regions that would be that the users would need. So we wondered whether defining like maybe numbers but for a specific region like ENSO does, like with the Niño 3, Niño 3.4, things like that, whether we could have like maybe a Bering Sea, a Barents Sea, a Labrador Sea indicator, whether that would be useful together with the uncertainties or not, and whether we are able to provide such metrics with uncertainty as well. Another thing, we said that a number of metrics have been developed in the past by the weather community, and in particular spatial verification that were discussed yesterday, and also some tendency methods. So we wondered what type of metrics then we could use for this specific problem and adapt which one would be the best. Also from seasonal community, so a number of us are also involved in some seasonal predictions. So what type of metrics we are using in seasonal prediction can be used here, and which ones are maybe less relevant. As was mentioned before, we said thickness is an important things we want. We want to be measured, and we want it to be a key metric. So I think this came up by a number of people. Then we said there's another point here that was brought up is the question of metrics here to evaluate the prediction are not necessarily going to be the same metrics than to validate the models that are used for the prediction. So are we going to be able to define like one single metric for the seasonal prediction of sea ice that will be also a metric to validate the model that was used to produce those forecasts? So a model could have a good metric could verify with a good metric for its mean state, for example, or its seasonal variability, but then give pretty poor predictions. So which question are we asking here? We said that metrics based on related to some atmospheric forcing would be helpful beyond pressure, so wind stress based metrics. And then what is that? Yeah. We said we would adapt general statistical methods that are out of the box to the sea ice community, like maybe some self-organizing maps or other techniques that have been developed by statisticians and used by other communities that could be used here. So at the end, the last point I would say that metrics are different for different time scale. Yesterday, one of the presentation reminded that, for example, dynamics rule on short time scales, but thermodynamics are more important on longer time scales. So we really need to define the time scale of interest for also the definition of the metrics, as we might be interested by a few days, like when someone mentioned that the date where ice-free zones, where a specific zone will be ice-free, or a date where passage will open, might use a different metric than a seasonal forecast of sea ice. So keeping the time scale in mind probably is useful. That's it.
Thanks. So we, excuse me, are on our last breakout group on observational needs. Group A, I don't know who's reporting. Uh-oh.
Thank you. So yeah, the 5 key ideas. The first one was to try to prioritize the needs. So from an external community to for a community which is external to this prediction community, sometimes it appears that we have many needs, many different needs, and it's very difficult to see what are the most important ones. So it's very a priority to try to organize our needs in terms of relative importance first, to be able to give to like funding agencies or whatever the relative importance of each task that we are trying to accomplish. The second step regarding the data themselves, of course, it's thickness data for thick ice and thin ice, which are probably the most important. Snow thickness is also very important, and we also brought up this idea that we would probably need in the future more data for the upper layers of the ocean, so heat content in the upper layer of the ocean to try to improve predictions. The third point was about the data format. So while there's a widespread use of data format in the community, we are all annoyed with using binaries. So if we can avoid using binaries in the future, that would be very good. We are thinking of NetCDF, which is a quite a largely used data format that we could converge to. The fourth point is about, of course, uncertainties, and I think this has come up yesterday quite a lot, that we absolutely need uncertainties. It's important when observations are released that they are characterizing what is the uncertainty due to sampling errors, due to representativeness of the area, but also uncertainties related to the instrument that was used to make the measurement. And also we have to be very careful when we use data that were interpolated from a very fine grid to a coarser grid, that these uncertainties are actually taken into account properly. And this is a very difficult task to take this into account. The last point is that we would like to have, as well, I'm speaking as modeler, but it could be best if we could have data that are near real time. So if we want to advance sea ice prediction for the seasonal time scale, obviously we need data as input for the models that is released as quick as possible. And this is not always the case from the data that is available now. If we have now a look at the longer term perspectives, then we think that the priority is to try to define who is going to centralize and to manage this data. So is it possible to attribute the job of managing the data to centralizing the needs in a common place where this could be so centralized to improve the management of the data on the long term? Mathieu told me it exists in France. They have such a kind of institute which is listening to the needs of the users, and it's centralizing all this kind of data to try to make this work optimal.
Yeah. Thanks, Francois.
Okay, thank you. So yeah, I think the first thing we noticed in our group was the clear discrepancy in terms of the needs of both the operational and seasonal forecasters. So I think the operational forecasters were more keen on having real-term, near real-time data, whereas the seasonal forecasters were potentially happier with maybe monthly means, especially with things like ice thickness. So I think determining what your model is going to be used for and its forecasting method is kind of key in determining what data is provided. So based on the ice thickness, I guess obviously we talked about some of this thin ice thickness data. So currently people seem to be using the SMOS data for this ice thickness less than 1 meter. I think this new NASA sensor was mentioned, the SMAP, is that right? Which could also provide some pretty accurate thin ice thickness data, which I believe is it launched October this year, but it could start to provide data by spring of next year. So that could be useful. Again, this is only going to be beneficial for thin ice. So then obviously the problem is what we do about the thick ice. And so that was a real kind of problem, and it wasn't really clear which data we thought was going to be best for that. So we discussed the buoy data and how some of that data is being made available through the Aeon network. How much the forecasting community is aware of that data wasn't very clear. So whether some of that data could be made or communicated more to the community would be good. I think someone mentioned that the buoy data was currently being used in some weather forecasting, so using the GTS, was that the Global Telecommunications something system, but that wasn't really suitable for the seasonal forecasting needs. So whether there might be another mechanism through which that data could be collated and provided to the community might be useful. Yeah, we also mentioned the ocean heat content, like Francois said. I think this is maybe more important for winter forecasting, I think we kind of say. So maybe the summer ocean heat content, maybe for the upper 100 meters or so, to the mixed layer, and also the temperature below the mixed layer, because that's heat that's going to be entrained in the following winter. So that's likely important. I don't know if we really discussed where that data was coming from, but if anyone has any, that would be good. We then mentioned SST. Again, this is kind of a simulation. I mean, I think we maybe got a bit confused with initialization and assimilation, but it was generally feeding data into models, and maybe SST data could be useful. We discussed the problems with SST data near the ice edge, which is kind of unfortunate because that's maybe where the big problems lie. But maybe some of the SST information further south could still be useful, as that's heat that's likely advected northwards throughout spring and summer. So that could be data that is useful in improving some of these forecasts. And I think that was being done by one of the groups. I can't see where he is. Yeah, I think Frank said he was doing some SST assimilation, right? Yeah. Where was your data from? It was OS. Yeah. Final points. I think we said clouds are kind of annoying. I'm not quoting anyone here. Obviously, we don't think cloud data would be a useful mechanism of initialization, but cloud information might be a useful metric. I guess this is maybe more point 3, that it might be some useful way of validating the performance of the models. But it's something that we should be aware of when running these models for predictive capabilities. And yeah, I think then the final thing is snow, which again, Francois touched on. And I think really the big problem seemed to be the understanding the scale length of some of these snow depth point measurements. Because I think we've seen yesterday that some of the ice thickness point measurements have been included into some of these assimilation methods. employing some kind of scale length to expand that data more pan-Arctic, but it wasn't really clear whether we could do the same kind of thing for snow, and it's likely we can't. So then we kind of hit a stumbling block and potentially gave up. And so, yeah, I think that was it. Anything else? No?
Thanks, Alec, and thanks everyone. Wow, we're on time. Amazing. And I'm afraid we don't have time for questions, which was really my hope. But we have a period at the end of 45 minutes where there are no presentations at this time designed, so we will have a lot of opportunities. So hold all your thoughts and enjoy an hour for lunch. Please be back here at 1:30. Oh, and Larry has